This is the memory allocation and garbage collection activity in C#. I have the whole folder here open in Visual Studio Code. We're not going to be actually running code, but I have this open here so we can take a look at some things. I also have the README file open. If you haven't done the research yet, please do that now. Pause the video, do your internet research, use your favorite engine, your search engine, or your favorite AI tool. But you want to research memory allocation and garbage collection for C# or .NET in general. It's really the .NET memory allocation garbage collection. We're just using the C# language within .NET. Take some notes, come back to this video, and we will get started. For the rest of this video, we're going to be exploring these bottom questions down here. How are objects allocated? How are they deallocated? The difference between managed and unmanaged objects. How can we ensure deallocation of unmanaged objects? Are there design patterns or specific types in the language that can assist? And can we interact directly with the garbage collector? So let's explore some of this really fast. I'm going to create a new file here. Let's just create it example.cs. And let's just create, public static class program. We don't make it static. So we'll create our class program. Let's create a public static void main method. And in here, let's just create some different values. So we will create let's do a private static int my value equals 3. And then let's create some variables in here. So we'll say var a equals 2.0, var b equals test. And let's do a quick loop. For var I is 0, I less than my value, I plus plus, console.writeLine, I, and then let's do a console.writeLine B. Let's actually move this around. I'm gonna, just so we can see how some of the actual garbage collection and execution would work. So our main is going to be empty. It's just going to call into execute. Execute will run, and we'll see how this code is going to run through, especially with garbage collection memory allocation. So starting off, how are objects allocated in memory? So objects are allocated in memory in C#. Whenever we run into an object that is an object literal, so 2.0 is an object literal that is a double type. Test in a string is an object literal. We can also have a character. We could have a Boolean value. We could have an integer, as we have up here. 3 is an object literal. So these are all inline object literals that represent specific values. Anytime the C#, the .NET runtime runs into one of these, it's going to create an object in memory. In addition, anything with the new keyword. So if we created a connection and set it to equal new connection, this new connection then creates a new object. We call that newing up an object. So the constructor is going to create it, or in the inline literal is also going to create an object and allocate that in memory. How are objects deallocated from memory? Well, basically the way this works is they are deallocated when we go out of scope for where the variable is declared. So for example, in the execute method, the scope block is defined by these curly braces, line 7 through line 16. Anything declared in there is going to be immediately eligible for garbage collection when line 16 is hit. So in other words, when the method is finished executing. So A and 2.0, B and test are all going to be eligible for garbage collection when the function finishes at the end of line 16. I is declared inside this for block. Because of that, I is eligible for garbage collection immediately on completion of the for loop. Now we can also create artificial scope blocks with curly braces. So for example, if I wanted B to be eligible for garbage collection before I'm done, I could then create an open curly brace, indent everything, and then close my curly brace. And now B is going to be garbage collected or eligible for garbage collection on line 17 instead of waiting for the whole function to end. So scope blocks, and in C# that is done through curly braces, are how we define when objects can go out of scope and therefore are available for garbage collection. My value is declared as a field inside program. You can see that it's nested directly inside program, which means that my value is not eligible for garbage collection until the my program or the program class goes out of scope. So once it's no longer used, which effectively happens when the app domain is unloaded. So in other words, when the whole program finishes, that's when my value would be available for garbage collection. So that's basically how objects can be deallocated from memory. What's the difference between managed and unmanaged objects? Well, in C# we can use unmanaged objects. We can reference values in memory or values in other resources that are not directly managed by the .NET runtime. We generally do that through a couple of different tools. One is through something called an int pointer. And an int pointer is a special data type in the .NET framework that will point usually to an address. It can point to a file handle, but it usually points to some memory address in memory where we're going to retrieve some value. So that's what an int pointer is. And so this would be the result of some call out to an unmanaged object. In addition, we can extern function calls. And so the way that might work, let's say there is a non.NET assembly, a native assembly, something usually built in C or C++ that we want to call into. We would need to find that function, and we would say public static and then match this signature, do something external. Not that that method is going to exist, but then we would use the extern attribute. There's a lot more on this. I'm not going to go into it very deeply today because it's not something that we typically do a lot. If you needed to do it, you could certainly do some internet research and find out how to do that on your own. But there is a way to call out to other assemblies that are not .NET assemblies, that are native assemblies. That's how we would do that. The next question, how can we ensure deallocation of unmanaged objects? Effectively, what we have to do is make sure that we're going to close out any endpointers we might declare. So whatever that might be, we need to put into maybe a try finally. And in the finally block, we want to have whatever code we need to do to clean up the memory. So clean up values in memory or file handles. And then we want to reset the int pointer, which I believe is the intPointer.0 implementation. And so that would zero that out. We could also just cast 0 to int pointer to reset it. So we need to make sure to do that. In addition, there are a couple of other patterns that are available. We'll get to those in just a moment with the next question, but we do need to make sure to clean this up. This is not going to happen automatically. It is our responsibility, since it's not managed, to clean that up on our own. The next question, are there design patterns and specific types in the language that can assist in garbage collection? Yes, there are. So there are a couple of different patterns that we can use. The first is the finalizer pattern, and the second is the disposable pattern. So the finalize pattern, let me show what these look like really fast. Let's create a class called myClass. The finalizer pattern would use the destructor. So the destructor looks a lot like a constructor, except we have the tilde in front. There can only be one destructor, and it basically says when the object gets disposed, call this code. So if I had an int pointer in here, this would be a good place to clean up int pointers or similar unmanaged code. So that is one way we can do that. That's the finalizer pattern. The other approach is the disposable pattern. The disposable pattern requires us to implement the iDisposable interface. Then we need to implement the iDisposable interface, which is a simple method called dispose. There's a lot that goes into this, so I'm not going to go too deeply into it. It's worth doing some research, but here we would clean up resources that we might need to do. And this has to do with the generations of garbage collection and how those objects get cleaned up, but these are the two patterns. So we have the finalizer pattern, we have the disposable pattern, and you can combine those into even a more robust way of making sure that things get cleaned up appropriately. So those are the patterns available to us in C#. Finally, can you interact directly with the garbage collector? Yes, you can. There is a class called GC, capital G, capital C, and it has methods that are available to us that we can interact effectively with the garbage collector. Generally, we want to avoid this, but there are some things that we can do to suggest a garbage collection event. Now, that's just a suggestion. The .NET runtime, like most managed languages, will determine when it really is best to run a garbage collection event, but we can suggest it, we can hint that it may be time, or even request it. There's other different methods available as well. That takes us through all the questions, so that concludes the memory allocation and garbage collection activity in C#.